I work at as a researcher at the Manchester Institute of Innovation Research. We're part of the business school at the University of Manchester. I have a background in biology and in social sciences, science and technology studies precisely. I decided I was going to start this talk by saying that once I saw a lecture, a historian saying, I'm a historian, therefore I'm going to read. I'm not a historian, but I'm going to read. Because there's a lot of things I want to talk to you about today, and also this is a part of the research, it's a upcoming sort of research that I'm doing. So this is mostly the background of the study that I'm developing at the university. We can talk more about what I do, I think, after the presentation if you're interested. So I should probably start this presentation by explaining a little bit why I chose this title. And in 1982, the year that I was born, the first version of Blade Runner was out in the cinema. It was based on a science fiction novel that maybe some of you might know called Do Androids Dream of Electric Sheep? That was published in 1968. The novel is set in San Francisco after a global nuclear war that almost made life disappear on Earth. The soundtrack of the film happens to be my mum's favorite of all times. And I thought it would be nice to pay a tribute to her and just have Blade Runner, you know, as or paraphrase the title of the book that is behind the film. Does anyone know about Vangelis, the soundtrack? Vangelis, the father of electronic ambient music? Okay, not very much people. We do know in Brazil, which is really funny, isn't it? Anyways, the other reason why I also wanted to paraphrase the title is because Blade Runner tells us a nice and timely political story. Although it might not be obvious at first sight, it's a film about AI and inequality in a post-apocalyptic world. In the original film from 1982, this happens in 2019. So that's only 8 months from now. It'd be great. Yeah, it's really interesting, isn't it? 8 months from now, it's the post-apocalyptic time after a nuclear war, which we thought it was going to happen maybe a month ago between the conversations, you know, the US and Korea, which is really funny. We need to keep track of, I need to make a note on that. So Blade Runner is really nice, but the talk's not about Blade Runner. And we can talk about why also the title of the book was Do Androids Dream of Electric Sheep later on. But in a nutshell, what I wanted to talk to you about today is that it's about algorithms and how they're political and social constructs, how the ways we design computer programs can reflect specific social imaginaries and social norms, and what could be the implications of this. As many of you know, we do use basic logics of algorithms all of the time. They exist outside computers. We use them, for example, to do our laundry or to commute every day. Algorithms are something that it's built in our natural intelligence. We also use algorithms for solving simple problems when a lamp doesn't work, for example. The building blocks of artificial intelligence reflect the way our own natural intelligence works when we make decisions, when we make value judgments, and when we choose between different options as well. So in this presentation, I'll be using a very broad definition of algorithm as a set of instructions which are built into computer programs, so these programs can perform specific tasks depending on the objectives and functions that we define for them. Malte Zievit, who's a professor at Cornell University, he talks about the existence of a current algorithm drama, or a seductive drama, about the role of algorithms in public life. The drama runs along the idea that big data and machines, which are fed with this data, become the responsible agents for making decisions that affect our lives, such as personalized shopping, or political campaigns, or the design of urban spaces. There are two acts in this drama. The first one is algorithms are regarded as powerful and consequential actors, which are pervasive in everyday life. Algorithms become universally relevant and become very democratic, at least in the context of digital societies. Look at your phones. You don't even need to have a laptop in this case. Algorithms are considered to have agency and autonomy in the sense that they become the imagined subjects of any potential wrongdoing. In the second act, we have the difficulties of explicating how exactly these mathematical black boxes exercise their power and influence. This is important when what makes them powerful is precisely the fact that they work as opaque black boxes. Some people might disagree on that, and we can discuss later, but they are black boxes to us, or to most of us, at least for me. So, for Zivitz, these two acts that I just went through, they encapsulate at least 3 analytic themes which have been of interest to what we can label as the politics of algorithms. These themes are agency, inscrutability or transparency, and normativity. And they have asked how algorithms may not be as autonomous as we think, but operate in the context of larger socio-technical systems, and how they are connected to specific historical developments as well. They also talk about the challenges of deconstructing and understanding how algorithms work. And what it's, I think, very relevant for us today is the intrinsic feature of algorithms as value-driven, as cultural constructs. As I hope to show today, these themes are entangled. To unpack them means to situate algorithms in a specific context, and to situate artificial intelligence in a specific context, within their broader political, moral, and societal contexts. So I propose a set of who, where, how, and what questions regarding algorithm or algorithm design to help illustrating that. First one is, who is producing, retrieving, compiling, and selecting input data to feed in algorithms and computer programs? Where is the data coming from? How is data being organized in order to build an algorithm? That is, how are questions being framed? And how is the algorithm supposed to look for an answer to the problem that is being defined? Finally, what gets included? And therefore, by consequence, what gets excluded when we train a computer program on how to behave? So I'd like to start exploring these questions by turning the attention to the process of development of computer programs to remind us that algorithms are not some orphan entity. However, we hardly question the identities and beliefs of people involved in programming, involved in building those algorithms. We don't question that identity. We don't know who they are. So here I draw on feminist critique of artificial intelligence to explore the issue of deleting the subject, which is a term coined by Alison Adam, who developed her work on gender and artificial intelligence in the 90s. She was actually based here in Manchester at the Department of Computation of the extinguished University of Manchester Institute of Science and Technology, UMIST. I only arrived in Manchester 18 months ago, so I don't know anything about UMIST, but maybe some of you do know about UMIST. The focus of this department was on the study of the interactions between people, software, and data in the application and use of computing. Alison talks about situated robotics to question the disembodied nature of knowing and perceiving, which is inscribed in the studies of artificial intelligence, especially in the studies, the expert studies in the science of artificial intelligence. She argues that artificial intelligence epistemology follows classical studies in epistemology, which assume that the identity of the knowing subject is irrelevant to the study of knowledge. That is, to the study of how we know the things we know. What we focus on the most is the actual knowledge represented in AI systems, but not on the identity of the people who hold this knowledge in the first place. This identity, again, remains unchallenged. Now, to come a little bit from theoretical thinking, a little bit more to practice with real examples, I'd like to explore how the knowing subject is represented or deleted in real AI systems. And Alice and Adam looked at 2 AI flagship projects in the 90s. One of them is Psych, which some of them might know is one of the longest-lived AI projects in the world. It was created by the American AI researcher Douglas Lennart, and in the 80s, he was supported by the US industry grants. His project extended for about 30 years or so, or more. Sometimes I don't even know if the project has ended. It's very ambiguous, but it looks like it has come to an end 2 years ago. So the symbolic logics of this project, so it's symbolic AI, have been very criticized by recent AI developments in neural networks and machine learning. But Psych entails fundamental issues which are shared with other approaches to AI, such as neural networks, and is a great example for the purposes of this presentation. According to Lennart, the promise of Psych is to build computers with common sense, a long-standing goal of AI systems. Roughly, this would work by constructing the most comprehensive ontology and knowledge database that would include basic concepts and rules of thumb about how the world works. That is, how an imagined average human believes the world works. Now, what I call the imagined average human is described in Adam's words as an individualistic, rationalistic, universal man of reason. Her epistemological critique is also a political exercise, as it is concerned with the hierarchical organization of knowers and the kinds of certified knowledge that get prioritized in the making of AI systems at the expense of other knowledges, of other people who might not be classified as experts or as certified knowledge. What this means is that different people and their knowledges are attributed different statuses. Now, going back to the case of Psych, the project's objective is to overcome the limitations of knowledge-based systems in understanding questions that seem really basic to us. Lennart gave a talk 2 years ago in Texas, a TEDx talk, where he exemplified the limitation of computer systems at the time. Well, not at the time, what was the motivation to develop Psych, and this talk was 2 years ago. So he suggested the exercise of posing the question to Google, who was president when Barack Obama was born? You don't get an answer here. But you do get an answer if you ask, who was the president of the United States in 1961? Or who was president in 1961? And this is because computer programs are brittle. That's the idea, or the metaphor is that they're brittle. And that's what Psych was trying to overcome. One simple example that Lennart offers of the kinds of common sense knowledge that Psych should have is how one might choose on how to pay for a certain product or service. Payments of less than $10 are usually made with cash. Those over $50 are usually made via check or credit card. For the Psych's founder, Doug Lennart, the answer is in building a robust, arguably universal library of consensual knowledge. In Lennart's words, this consensual, universal knowledge is independent of the person possessing such a knowledge, be he or she a professor, a waitress, a 6-year-old child, or a lawyer. Psych was not so much about building an encyclopedia, although Lennart's background was in building an encyclopedia before in the previous project. But it was about representing the consensual knowledge to understand an encyclopedia, the information in the encyclopedia. When Adam was doing the work looking at Psych, she was looking at how Psych embedded different theories and multiple models in relation to a single theme to argue that the design of Psych is not neutral, is not value-free in the way that handles the knowledge diversity, especially when resolving conflicts over contradictory information. In her own words of Alison Adam, the models used reflect and privilege the viewpoint of the developers of psych. And that viewpoint is that of the middle-class, Western, professional men. Realism is a contentious notion in philosophy, and the pervasive notion in AI and in the hard sciences. Which claim to be objective and value-free. It rests on the idea that we can access the state of the world, or the state of the real world, through our sense perceptions, and that there is an independent and consensual idea about what that world means to non-weird people. This is from traditional epistemology, would call non-weird people. People who can see the world in a universal, consensual way. So who is to judge, for example, the statuses of competing theories in a given area? For example, Marxism and laissez-faire capitalism. They are already straightforward examples of competing theories in economic development. There are also many other alternative models which might be given much more limited attention. I don't have the time or the expertise to go through these books in economics. But this is just to point out that the idea of, or the ideal of an average man of reason is unlikely to prioritize any alternative accounts of how the world works or how it should work in comparison to mainstream views of economic growth and development, for example. It makes us wonder what psych would be thinking about in terms of economic positions being funded by the US industry. The point that Adam makes in her research is that Leonard presents economics as inexact. Therefore, we should expect the existence of multiple models to explain economics. By doing this, Leonard implies that other areas of knowledge are potentially exact, and therefore might not need multiple models to explain them at all. The problem is that the decisions on which areas are susceptible to theoretical diversity and which are not, and on how we should best characterize this diversity, are normative and extremely contentious. As Adam suggests, in order to show common sense, psych needs at some point to decide on whether it is a capitalist or a Marxist, a Christian or a Jewish, a male or a female, old or young, middle-aged. I would add to that fact that each of these categories are not only complex, but also unlikely to be found aesthetically in the ways people mobilize their arguments in process of interaction and socialization. Final issue that was identified by Adam is that of how psych differentiates between knowledge and beliefs. Psych attributes greater status to knowledge by assuming that it represents indisputable facts and are therefore a representation of truth. Beliefs can be supported by what are claimed to be truthful facts, that is, knowledge claims, or by other agents holding similar beliefs. That means that more of us believe on something, the more chance it has of achieving a status of knowledge, when the people believing on something are in a privileged position. Leonard considers beliefs to be the opinion of minorities. In Leonard's words, co-believing communities make it easy to propagate rumors, prejudice, and superstition. These beliefs, consequently, they get assigned a lower status than that of knowledge. In 2016, The Wired magazine published an article about the current status of psych, 35 years later after the project started. Something that goes unnoticed by the work of Alison Adam that I was talking about before, but that is picked up in this article, is that Leonard's wife, Mary Shepard, was also part of the initial team of scientists. Not surprisingly, not only Shepard's contribution to psych is invisible in most of the stuff that I read, her role in the project changed from scientist to finances manager. But another relevant point I'd like to highlight here is that the way the coding language started to be developed and taught to psych was through Shepard and Leonard first telling the system about themselves and teaching the system about the kinds of knowledges and beliefs they held in the first place. I need to note that I should note that this is not different from recent research in human and machine learning, such as the one developed by Deb Roy. He's the director of the Laboratory for Social Machines in the MIT Social Lab. With the help of his wife, Rupal Patel, the MIT professor, an AI researcher, uses his own home and the processes of socialization and learning experienced in the everyday life of the family with their first child, who's now, I think, 3 years old, to gain insights on how to teach robots the way we teach babies, or how robots can learn the way babies learn. In this case, we are talking about a particular baby from what is apparently a well-off American family who may also fit in the heteronormative model of parenting. Compared to the high-tech, slim and smart figure of Roy, this picture of Leonard back in the 80s shows a much different profile of a man who was highly regarded at the time by investors who were then in search of the perfect 80s nerd. Now, this photo is included in the article published by Wired only 2 years ago that included the photo I showed before. Although it was published only 2 years ago, the title of the article reproduces the same idea of an individualistic version of the rational, equal genius, man, who is entitled to teach machines how to think. The title says, "One genius lonely crusade to teach a computer common sense." This is not much different from the research being developed by the popular and contemporary Deb Roy. And it also includes the word crusade. As we all know, and according to the Oxford Dictionary, the term crusade refers to the medieval military expeditions made by Europeans to recover the Holy Land from the Muslims hundreds of years ago. I guess it's not by coincidence that he has the army next to him in this photo from the 80s. So this brings us to the second issue of the fabrication of imaginaries of social life and social order around AI. This critique is essential and fundamental to feminist theory, which focuses on the absence of standpoints of the other. That is, on exposing inequalities not only in relation to gender, but also with intersectional implications to class, race, and sexuality in the context of white, male, middle-class, heterosexual models of authority in Western societies. Specific imaginaries of social life and social order are reproduced in the arts and the sciences, and in pretty much everything we create and design as cultural beings. They include ideas on how we ought to behave, depending on our societal status. They also produce and reproduce stereotypes, which become hegemonic and commonplace. With time, these stereotypes become normalized and eventually invisible. In the abstract of this talk, I suggested you do a quick search on Google for fashionable clothing and unhygienic food. Did anyone try that? Nobody tried it. Okay, so I'll give you 5 seconds if you can see the photos, because there's a lot of light, to inspect the images and see if you find any patterns and differences between them. Okay, 5 seconds. Good. Yeah. Now, this exercise was inspired by the controversy sparked by a tweet from Miss Botswana in 2016, who Googled unprofessional hairstyles for work, pictures on the left, and professional ones, picture on the right, to find an explicit racial divide between Google's opinions on what are desirable or acceptable and undesirable or unacceptable looks. Google uses different secret algorithms to search for pages and rank pages. One of its first algorithms used to rank pages is PageRank, developed at Stanford University in the 60s. Now, that other algorithms I have no idea about. But basically, the original one measures the importance of web pages based on popularity. More links to a page, better ranked it is. What these results are showing us is the societal prominence of stereotypes. I must admit I got a bit obsessed with these exercises of Googling things and looking at stereotypes. And I did another one, which are the differences between an ugly, a neutral, and a cool robot, according to Google Images or according to how popular web pages are to us as internet users. So this is the ugly. The first one is the ugly robot. What can we appreciate from the majority of these images? They look a bit silly, don't they? They look colorful, they look small, quite simple, old, right? This is the neutral robot. It's just a search robot. Very different from the other two versions. Very muscly. Some of them, not all of them. Sometimes they have blue eyes, white tones, look like humans. And the cool robot. Cool robot is very different from the other ones. Very, very muscly, kind of angry, darker tones. They look like really a genuine male warrior, which is whale, if you mix both words. Which is not a funny joke, I know, but anyways, I made a mistake, our pronunciation. But anyways, it's pretty different, isn't it? What's ugly, what's neutral, what's cool? So going back to our discussion on social imaginaries, the Western computer sciences was imagined and built as an essentially masculine field, one where specific representations of masculinity were mobilized. When we talk about gender, it's not just about women, it's also about men. So this follows a Christian tradition where men tend to be regarded as rational and women as irrational. In fact, as David Noble has shown in the book, science in general has been developed from a monastic system, from male monasteries of medieval Europe to the celibate masculine world of universities. Universities were spaces where women did not exist. Orthodoxy rejected sexuality, and heresy became correlated to contact with women. If you have contact with women, you're a sinner. Women became a threat and a source of fear to the male ecclesiastics. Clerical celibacy became the social norm in the 11th century, just when universities were starting to be founded in Europe. These universities did not have any women in them. They represented a world without women. That's the title of the book by David Noble. To make sure that one can grasp how deeply entangled science and religion have been, it was not until the late 19th century, that's 1882 precisely, that fellows of university colleges of Oxford and Cambridge universities were allowed to get married to women. Not to men, obviously, 1982. If anyone does not believe in me, there's a whole thesis, really nice one, that was written about the subject of the ban on marriage in those two universities. And this is highly interesting stuff. But going back to the computer sciences, which its origins are just some 50 years after the rule changes in Oxbridge about marriage, the imaginaries of masculinity also follow more contemporary gender politics of corporate society. Between the 50s and the 70s, data processing departments were very hierarchical, and although women were included in them, they were responsible for conducting the more manual, lower-paid jobs. This would typically involve work, key punch work, that is data entry work. The upper roles in the hierarchy were dominated by white males who would take the lead as programmers, system analysts, and managers. In fact, association to key punch work was considered a threat to masculinity. It was seen as a feminine skill. From this followed a systematic denigration of women's capabilities and of femininity altogether as a perceived inability or biological unfitness to perform certain tasks. At the same time, a preference for a certain type of masculinity was also mobilized. An ideal manhood that reflects the societal norms of the time and which continues to a certain degree still today. These social imaginaries were reinforced by early studies in the biological and cognitive sciences, of which we see still today some exemplars as well, especially in relation to gender and commonplace attributions of certain characteristics to males and females. The conventional wisdom of women as less capable and less intelligent than men to conduct tasks outside domestic work have been picked up by society for many decades, and they're still embedded in our imaginaries. One simple current example is the commonplace belief that girls and boys have different ways of learning. This is based on the assumption that these differences not only are universal, they are also considered to be biologically determined. If you look at a web page of a school for girls, some of them would pass that message, that there are biologically determined characteristics that make boys and girls have developed different ways of learning, and that's not true. But I'm not going to discuss that literature now, but that's not true. We might think that the gender politics of computing are changing, and that women's underrepresentation is part of the past. However, there's some really good recent sociological research showing that that's not quite the case. In fact, in countries such as the US, Canada, New Zealand, Australia, and member states of the EU, the number of women entering computer and information technology degree programs not only does not increase, it actually has been declining in the last 20 years. This is despite of many initiatives to reverse the trend. If the trend continues, in 15 years' time, in some of these countries, we will see no women graduates in computer sciences. Science, technology, and gender constructs have shaped one another over time. The same holds true for other social qualifiers that intersect with gender, such as class and ethnicity. Ulf Malmström has shown that not only these other social qualifiers need attention, different cultural contexts can also show us contrasting scenarios. I have focused so far on the Western world, but Malmström, who's an anthropologist, investigated the computer sciences in Malaysia to find a field dominated by women. But what Malmström also found in the post-colonial context of the Malaysian society is that females also dominate low-skilled technology work, and that the status of working with computers is mediated by a specific cultural politics, where working on IT in the indoors space is regarded as a role and space to be occupied by women. In a similar vein, that the indoor space of the home is the most suitable for women. The way IT works the way IT work gets gendered and conceptualized is very different from the social imaginaries and norms of the Western world. Still, you can see that the reconceptualization is still discriminatory. Another interesting finding from his research is that women's inclusion seems to be favored by a successful race-based quota. Is a system implemented in universities that privileges the Malay ethnicity, which is the lady in the middle, over others, like Chinese and Indian backgrounds, which are discriminated minorities in Malaysia. That means that a sort of positive ethnic discrimination has had a more important role than gender, while it had also increased the possibility for women to be enrolled in university degrees, if they are Malay, not Indian or Chinese. One point to note here is that the level of women's inclusiveness is higher for Malay women than Chinese women, like I just said. We could extrapolate this to inequalities between Western white and black men, but also between white and black men in Malaysia and women. By now, outlining some of the potential implications of hegemonic views and discrimination in the foundational fields of AI, such as computing and computer sciences, should hopefully bring us to a more straightforward task of discussing, so what does it mean for us in practice? So if I can just put roughly and summarize in a line, through learning, machines will inevitably reproduce human biases and mainstream stereotypes. But as we know very well, we're not all the same. We're very different in a lot of ways. Automated intelligent systems are supposed to help us solving problems. So the question of who's us and who are teaching machines how to learn and how to solve our problems is a very important one. The issue comes down to how are AI systems supposed to judge and choose between good and bad, acceptable and unacceptable alternatives without having embedded in them a certain code of ethics. But if they do have embedded in them a code of ethics, one should also ask, which code of ethics would this be? In the case of AI systems, if they are intelligent enough to avoid the reinforcement of certain stereotypes, how would they identify a detrimental stereotype in the first place and differentiate it from a commonplace, potentially harmless characterization of the world and its diverse people? Many questions here. I'm going to jump to some recent examples. The first one is about design and effective computing. So Stephanie Rukavina and her colleagues, they argue that some subject-specific variables influencing speech and facial expressions get overlooked in the developments of effective computing. These are gender and age. So they argue that emotion recognition is less accurate when we don't take those aspects into account. The interesting thing about effective computing is that the effective subject is the human interacting with the machine, not the machine itself. The objective of effective computing is to influence, hopefully in a positive way, our emotions through our interactions with a robot or with a computer program, with the machine, whatever it is. So what the authors were hoping to do, or they actually did, was a real-time classification algorithm for electroencephalography, and to help increasing the accuracy and the complexity of classification, gender and age. I'm not going to go into detail about their research, but the point is that this is a good example of how the classification of emotions is dependent on the features of specific subjects who are used in the development and the design and the choice for specific algorithms, which are expected to enhance the behavior of the computer system. That's the sample that they used. So which kinds of groups are represented by these subjects? And how can we ensure that they are representative of people with different cultural backgrounds, ethnicities, disabilities? Second example is about female and male discourses on Twitter during the Brazilian elections. Now, this is not Brazilian elections, obviously, but if I put here any Portuguese tweets, nobody will understand anything. So these are funny tweets from the last US election. So we've got some women up there, some men, and Trump himself saying a few things during the election. So these guys, they try to suggest a profiling and classification to apply to the development of algorithms for targeted advertising. What they looked at was female and male discursive strategies in Twitter political hashtags during the Brazilian elections. They do recognize that the discursive patterns are not biologically determined. They argue that the discourses are reflections of social cultural situations. They even cite Simone de Beauvoir in their paper, "One is not born, but rather becomes a woman." What is problematic in the way they applied, they promised the application of their profiling and classification, is that they assume that the gender of a Twitter user can be accurately inferred by using generic Portuguese full names, which is what they did to infer the gender of the user. Full names that are typically attributed to males and females. When you go on the internet, names for babies, then that's the kind of thing that you find. That's what they used. But what is even more important is that they propose a classification on behavioral patterns based on a notion of gender and a sex difference, male, female, without problematizing the potential reinforcement of binaries and stereotypes created by their classification in the first place. So it's really, really funny that they put Simone de Beauvoir in their paper. A third example, and a final example, is that of the design of automatic user profiling systems, which is similar to the other ones, and how people interact with web applications. The reason why I chose these examples over robots that do things like move and stuff is because, at least from the AI experts that I've heard, these are the actual AI things or applications happening right now. It's about profiling, it's about classifying, so that's why I focus on them. So Javier de Andres and his colleagues focus on gender and age again, this time to identify and classify users' needs and preferences. They hope the results of their studies can lay the ground for developing AI systems such as neural networks and decision trees. In their experiment, they used a sample of 592 individuals that would perform 5 complex tasks: point and click, drag and drop, text selection, text addition, and menu selection. They found that 1, men perform significantly better than women when executing interaction through pointing and dragging when using a computer, not the other tasks. And 2, older people perform worse in all interaction tasks. The idea is to use these results as a basis for classifying users and developing a tool that can be used by information systems companies. The hypothesis used in the background of their research is that men and women, boys and girls, have different capacities to carry out certain tasks built in their minds and bodies. This reinforces, again, the old paradigm, which has been very hotly contested in public and academic spaces. The subjects studied were users of a large discussion forum, and they invited their friends to participate in the project. Nothing about the background of these performers or these knowers is disclosed. We don't know anything else but between 2 types of fixed gender and the age of these people. So we're using reductionist and biased approach. I'm running out of time, right? That's why I'm reading, otherwise it would be even longer. Using reductionist and biased approaches, studies like this account for a good part of the result of the research being developed to inform classification systems through data gathering agents hidden in the user interface, which is exactly the phrase that they use. Not only the results are likely to influence the application of such systems in the real world, they are establishing problematic assumptions about users' behavior, which are likely to maintain long-lived and contentious assumptions about men and women's abilities to perform certain tasks again. Age and gender seem to be very popular variables, at least in the examples that I showed. Maybe that's because they might sound less controversial than race or class. Or maybe that's because one assumes that they are more visible, thus more quantifiable. Or worse, if I want to be really cynical, because race and class would be taken for granted in the development of the kinds of AI systems that I just included in this example, the average subject imagined here would be a middle-class consumer who is probably white. So how do we represent diversity? I would like to finish the talk by highlighting something very obvious. Algorithms only exist because we imagine and we create them. So how can algorithms represent human diversity? As a set of instructions on how certain computer programs or intelligence systems should work, they become normative instruments which support designers, firms, and policymakers achieving some predefined goals. They are the essential mechanisms through which intelligence systems simulate and potentially learn. The power and agenda of artificial intelligence reflects our own power and our own agenda, and we should be reminded that AI is not autonomous, nor is self-determined. As such, it doesn't have free will or intentions. The hype of big data and the promises of endless possibilities for creating new things all of the time and solving every single problem independently of human help has shadowed this and prevent us from having more constructive debates on what we want AI to do for us. The subjugated, that is, the excluded groups from hegemonic worldviews that typically inform research agendas and policy making have a vantage point. This vantage point needs to be included and trusted in the design of AI systems. Knowledge and technology and innovation is irresponsible if we cannot find who's responsible for making it in the first place. By not asking the who, the where, the how, and the what questions, I just asked in the beginning of the presentation, we might fail to realize more responsible and socially just forms of AI. Thanks very much.